Hello, and welcome to Lesson 8 of Learning Python. Today, we actually start working with the OANDA API. So that means we have to get the information we need to actually be able to use the API. So I'm logged into my OANDA demo account right at the main screen. So the first thing we need to do is we need to get our API information. So we need to go to the Manage API section. Now this brings us to this point here. Now before I go any further, let me make clear you should never expose your bearer token, ever, for any reason. This gives control to your account. So when you click on the Generate button, it's going to give you a bearer token. That token is going to be the basis of which your account will be controlled. If this information falls in somebody else's hands, they will gain control of your account. Be sure you protect it. Now I'm going to go through the process here so I can demonstrate it, but rest assured after this video is over, it will be destroyed completely. So you simply click on the Generate button, and then you get a token. This token is specifically linked to your account. So you're going to want to copy this, because we are going to have to put it into a text file on your VPS so that your program is going to be able to actually connect to OANDA. Once you have copied this information, go back to your My Account, and now we go to the Launch Web, or OANDA Web. We've got the bearer token, now we need the account number. If you remember from the last video where I went through a brief overview of OANDA, you'll remember just how important this information is. And you have your primary account number, let me find my mouse, right here. You also need to copy this, because both your account number and your bearer token will be used for the communications of all transactions with OANDA. So now that we have this information, let's close this out and go to our VPS. So I did just that. I copied the account number and the bearer token into a file I called credentials.txt. This file will be loaded by our program to pull this information. Remember, don't ever give this information out to anyone, ever, for any reason. Protect it. So we have that. So now let's bring up the program itself. I've written the program out ahead of time because a lot of it is learning the library versus learning the language. And the library is by itself tedious in many ideologies and respects. So our very first OANDA program starts out with what we've already seen, the 2 lines that let us run this program directly from the command line. Then our 2 system libraries that we will use a lot. And now comes a whole mess of stuff. And this is where things are going to get confusing and ugly. This is what you need to communicate with OANDA. All of these lines. And in this, we are introducing a shortcut. The as statement is a shortcut that lets us type just this instead of all of this. Now, it can be abused and overused, but when used properly, it makes your code far more readable. One common thing you will see in Python is import pandas as PD. The pandas library being shortened to PD. I personally don't think it's worthwhile the effort. You're only saving 4 characters versus all of this being shortened to just this. So you want to be aware that while these conveniences are available, be sure you use them appropriately and properly to your actual programming. Any good shortcut can turn into a mess that makes your code unreadable if you don't follow proper steps of using it. So here is all of the headers you need to talk to OANDA. But there's one problem with all of this that I actually forgot to mention, and I really do need to mention. You have to have this on your hard drive, which means more than likely you are going to have to install it. So before we go any further with this lesson, we need to make sure you get the library. So let me get out of this, and that is simply pip3 install OANDA Py. Let's see if I remember it. And I didn't. I forgot the V. Now, I already have it on my system, but you need to do this to have this library on your system. If you don't, Python will give you an error that you're missing the library. It's not a critical situation. As you can see, it's easily fixed, but you still need to have it. So now that we do have the library, let's go back to the program. So all of these lines are required for the OANDA library. Now let's get into the actual first stages of the program. Other than using special functions you haven't seen before, this is everything you've seen to date with a few twists. And we're going to cover those twists right now. Let's start with setting up this special set right here. This is what I talked about a few minutes ago. We are loading your credentials into a special data type Python calls a dictionary. But we are using a special function out of the library and out of the path sub area called exists. We just can't load the file without first checking that it's actually on the disk. So what this does is actually, does this file exist? Credentials.txt. Is it really out there? If it is, open and read the account ID and the bearer token into two special variables. And there's even more to this line in that we introduce a special function in Python called strip. Strip takes out unwanted characters that might be in the line. When files are stored on disk, special characters are put in them that will cause problems later on when we want to use the data. So strip lets us remove those special characters. And I'm going to go through and actually demonstrate exactly how this works. Then, of course, and most importantly, as you saw from our Safe Hacker 2 example, you need to close the file properly after you've opened it and used it. And just in case, if the credentials file is not there, meaning it doesn't exist, we tell the user they have to have it, and then we stop the program. We cannot continue without this file being correct. So let's actually go into the interactive portion and look at just these lines. So let's go Python 3. This is the interactive editor. It lets us test all sorts of commands. So let's start with opening the file. Open. And we want explicitly to read it. So for the purposes of the interactive portion, I'm using F to represent the file handle or the file data. Check our spelling. And, well, what do you know? We can't spell worth a hoot. And of course, it would help if we actually put the full name. Whatever you put for the extension, you have to put everywhere. Okay, the file is open. Now, what information does Python really give us? Well, we can see. We can see that it's a special file I/O wrapper. Now, we don't need to see all the nitty-gritty details because that just gets to be a big mess. But we have an idea what's going on. So now, let's actually L line equals F dot read line. So we're going to read the line from the file and store it in a variable called L. Now let's see what L holds. And here is why we need the strip command. Let me get the mouse here. See this funny \n? This is called new line. If you have Windows or Macintosh, it doesn't matter. Every operating system stores special characters at the end of a line of text so that the computer knows when the line has actually ended. This is what the strip command actually takes out. So if we type l.strip, you'll see that the new line or \n is removed. You have to take that off, because if you don't, when we go to communicate with OANDA, that new line actually changes your account ID. This is not your account ID, and OANDA will look at the entire line, including this weird symbol at the end of it. So you have to make sure that the account ID and the bearer token. For example, we can do this all in one trick. Read the second line and clean it up all at once. Our bearer token is the same way as our account ID. You have to take the funny characters out of it and off of it to make sure the program can read it properly. And most importantly, you have to close the file. You cannot leave a file open that you're not using, otherwise at some point your computer will not be able to open a new file because you have too many open at once. As wonderful as computers are, they can't just open every file on a hard drive all at once. They just can't handle that. So now we stored this information in a special variable Python calls a dictionary. Let's actually talk about that now in terms of exactly what is a dictionary. Okay, well first we create an empty dictionary. So we're going to have C equals bracket bracket or curly brace curly brace. Now a dictionary, let's have and let's have okay. Now this looks strange, but remember what I said about key value? Well, Python has a very unique situation where variables can actually store keys and values in the variable itself. So let's see what that actually looks like. And here it is. The variable C has a key and a value for name and car. So if we simply want to see the name, and these are case sensitive, so we will see a lot of this later on, as we will see this develop quite extensively, and it is one of Python's best tools available because it can help you manage large amounts of data efficiently. But it goes beyond just data. This whole structure is in a native format called JavaScript-oriented notation, or JSON. JSON is pretty much how most web-based systems communicate and relay information, and we will see that very shortly as well. So as you can see from the file system and from the dictionaries, we've created one single variable that can hold two pieces of information. That is, we have our credentials, something that we're going to use a lot throughout this whole process, stored in the variable credentials. So instead of having a lot of things that don't correlate together, we're able to actually group information into containers, or what Python calls objects. This is just one kind of an object. And as we progress through this series even more, we are going to see more and more types of objects that really make this a breeze to work with, even with the unusual layout that this dictionary, or that this library really has. So let's start with the next step, actually logging into OANDA. Now remember what I said about the try except. It should be used in situations of the network or things that you can't predict. And that's exactly what we're doing here. Try to log in to OANDA with its API using the access token of the bearer token. Now this sounds confusing, but it's really not when you think about the progressive steps we are taking. We need to verify our account with OANDA. That bearer token is our verification to our information. If anything goes wrong, take the exception, save it as a special variable called error, and then actually print the error. After that, exit the program. We're done. We can't continue because something went wrong. That could be a typo, that could be a network error, or it could be a dozen other things. But whatever the problem, we can't continue if any kind of error takes place logging in to the exchange. So as you can see, just right here on this one page, we have a lot of things going on. And it's only going to get more as we progress. So let's start with the next step. We need to load the markets. If we want to trade Euro USD or USD JPY, we need to be able to pull the market data. What markets can we actually trade? Here's a very critical step that must be done. You need to be able to verify what you can trade. You just can't trust that a market may or may not be on the exchange. And you need to verify it that that market is available for your account ID. You see, with OANDA, different accounts have different markets available to them. So my markets that I can trade may be different than your markets that you can trade based upon legal jurisdiction or other legal criteria appropriate to you as an individual and your account. So here we have a lot going on, but we need to find out what's going on. So let's make a special function to help us see what's going on. So like we demonstrated, we're going to make a function simply called showStop. It's going to have a variable. And my spelling really sucks today. So remember the colon at the end of the define line. Very critical. Remember, all functions must be indented from the title. This is going to be a very simple function. We're simply going to print variable. And then we're going to call the system function to exit. Now I'm passing a 0 to the system because this is not an error. This is me deliberately wanting the program to be stopped. So now that we have the function called showStop, let's actually see what we get. Well, first of all, if this succeeds, I want to see what it is. What's going on here? What exactly is OANDA giving me back? That's important, and that means a lot. So let's start here. I log into the account. And it's giving me a special object. That doesn't tell me much, but it's kind of like the file handle we saw earlier. And that's where we go next, is seeing more details from that information. So we know we have a legitimate object. We know we have some kind of connection with the exchange. So let's take this line out. And again, we're setting up a dictionary, an empty dictionary, but we're asking for the instruments on the exchange. Give me a list of what's available. Let's see what that is. What is OANDA actually going to ask for? All of OANDA's commands have this kind of a setup, or I should say all of OANDA's functions. There is some kind of a function that prepares a request and then returns the request for you to give to OANDA. So let's see what that request is. We'll run the program again. And here is the request. Now this connects to OANDA's API. And OANDA actually has a very elaborate document that covers that. Here is OANDA's website that goes through and talks about the requests that are given by the OANDA library. For example, here is the one we just issued, and it describes in detail what each component of that actually is. It's important to understand this to some degree, but not something to memorize. And you can find the website very easily simply by searching in a search engine for OANDA v20 API. And it will bring you to OANDA's direct website that talks about all of this information. So if you want to know more, here's where to find it. So now that we have a little bit more understanding about what this means, let's move on to the next step. We see the request. Now let's see the results of that request. What will it give us? Okay, so we have the results here. Let's actually see what happens. And it gives us a lot of information. A whole lot of information, actually. Now, we can clean this up. And there is a way, but it requires a special library. But we're going to do it anyway. This library comes with Python already, and it's one you will use quite frequently. JSON, the JavaScript-oriented notation. Remember I said that everything coming back from OANDA was automatically in JSON. Well, there is a nice little command where we can pass these strings into to give us results we can actually understand. Now we want to dump everything into a string. And we want to indent equals 2. All indent does is just clean it up where we can see it understandably. It makes it so that we can read all of that mess. So let's actually save this. And we're going to use a Linux command that causes the screen to be shown in pages, where we can move back and forth and actually examine the results. It doesn't work everywhere, but for the case that we're using, where we're dissecting sections of the program, this is a wonderful tool. Okay, now we have exactly what OANDA gave us, broken down into a meaningful and simplistic way. We can actually see in every case key value, and in the case of this key here, the value is actually a list or a large number of objects. So you see how this can get complicated because you can nest different objects within one single key. And this is very common when you ask for candlestick data or stuff of this nature like instruments or an order book. You'll see this nesting quite frequently. It looks intimidating at first, but it's really not, and it's very easy to work with, which is why it's such a popular format. So we see the very first asset is the NZD SGD token or currency. Now you'll notice it has an underscore versus a slash. That's because that's the way OANDA stores information in their format. Now using the less command, you can see I can actually scroll up and down and look at all of these various functions. And there's a lot of things here, a lot. It's going to take you time to really go through and understand all of this information. You're not going to get it at one time. But one thing you will see is, for example, whether or not you can place a market order or a limit order. There are restrictions to how you can trade Forex. If the market is open, you can place a market order. If the market is closed, you can only use limit orders. And all of that information really is clear. For example, here the market is closed, here the market is open. So you won't be charged for finances of shorts when the market is closed, which is a good thing because you can't actively trade. Now here we have another currency, or I should say the second currency in this list. And the same thing, you get an idea of exactly what the minimums are, what is allowed, what your margin fees are. a lot of information, literally. And quite frankly, it's difficult to absorb all at once. So you really need to take your time and slowly take all of this apart, like what we're doing. And you will be going back and forth between your VPS and OANDA, looking up information as you learn the API. And you learn OANDA from the inside of the API. This is a whole different world than traditional trading, where you just look at the chart and you get a wealth of information right there to tell you everything you want to know about the asset. None of that is given to the computer. You have to get all of that from this type of information. And it's tedious at best. At worst, it's downright confusing and it can be a nightmare. And that is really the whole point of working at this level. Because you actually are given more information here than you are on the exchange. You see literally the inside details of the exchange itself, the inside details of an asset. And those details will give you a wealth of information you can use. Now, when you're done with using the less command and looking through the data, press the Q command, Q key, and that will quit, and then you can go back into the editor and we can go through the next steps. Remember, the JSON library has a function called dumps. That is, dump in string format the result OANDA just gave you. So now we go through all of that we just looked at. And specifically, we want to focus on the instruments. We get this out of looking at that list. It takes a little bit of figuring out and trial and error. But once you get the basis of it, then you are able to begin to tear down and see how these components fit together. So we are going to go each and every one of all of the items in this list. And we're going to assign every item one by one to the variable cur, short for current. And now as I demonstrated with the actual raw data, OANDA puts an underscore in between the two parts, the left and the right part, or the base and the quote. We want to see it more traditional. So we're using another special modifier where we replace the underscore with a /. We also want to make sure that the name is in uppercase only. And as you can see, we have a dictionary. So one whole coin or one whole asset is in this dictionary. Let's actually see that. So out here, let's take this asset and let's see what's actually going on. Let's see cur. What does cur represent? What is really given to us from this list? Let's save it. Let's exit. And let's run the program again. Now we don't need less this time because we're only going to get back one single element. And it would help if I spell it right. Not exactly what I wanted there, but oh well. Okay, here we go. One object, one element. Now I'm not going to expand this out because we've already seen what that looks like. But we can see here the name, with the underscore, but then OANDA gives us the actual display name with the slash. We could just use the display name, but that kind of defeats the purpose of learning what's available and what we can do with the information we're given. So I chose to simply go through what I could do within the system. Everything we saw previously, but only one single asset. So now let's go back into our code. Let's get rid of this, and let's go get the next section. Now that we've got the asset, and we have it appropriate to what we want, we're going to use this for display later on. Here we want to take the name of the asset as OANDA says it should be. This is with the underscore. We're going to assign it to a variable, and we're going to create a special dictionary that OANDA requires. Now we're going to give it that dictionary, and we're actually going to pull out pricing information. So we're actually going to pull down and request the ticker. Let's see what that looks like. Take your time with your programs. Tear them apart. Every time you work with a part of the API, see what it is actually giving you. See how it fits together. Because some of it isn't intuitive. Some of it is actually quite complicated the way they did it. And here we are, the actual ticker price. Current ticker for this asset. And we see the actual time in milliseconds, the prices, the time of that price, the bids, and the ask, and whether or not the asset is currently tradable. Is the market open or not? So you see a lot of information and the confirmation of your instrument. You see the liquidity of it. Liquidity is important because you want to make sure you can get out of what you buy. You see the bids and the asks, which is what you're going to pay when you buy and sell. This is how you make your decisions. This is how we actually begin to really see how we are going to be able to trade for a profit this asset. Okay, so now that we know that, let's go back to the code. Let's take this out. And out of this weird output, here is how we actually get it. Ticker, and then you go for price. This is a bit weird, and it took me some time to figure this out. This is actually a list. So you can have more than one asking price in the list and more than one bid price in the list. In essence, you could have a history. So we want out of the prices table, go into the asks table, and then pick the actual current price, the most recent price of the ask. Now remember from our previous lessons, we need to convert it to a number. It needs to be a floating point number or a number with a decimal point. And we're going to introduce something new here. We don't want weird numbers that are 16 digits long. So round it to 5 digits only. We want our numbers to look right, to look proper. We do the same thing for the bid price. And we calculate the spread, the difference between what we buy and what we sell. Remember, that's what we pay as a fee to the exchange. Let's see what this actually looks like. What are we actually creating? How does this dictionary look to the computer? And this is a mini dictionary. As you can see just how important these are starting to become. So here we have our mini dictionary. We have the asking price, the price we pay if we buy it. We have the bid price, the price we pay if we sell it. And we have the spread, the price that is our fee when we make a transaction. And this is read as 2.9 pips. Remember that a pip is 0.0001. So this is read as 2.9 pips. So now that we are building another dictionary, remember we initialized the markets above, so we have another dictionary that is the key of the asset name. So whatever asset we're working on, we are collecting the bid, the ask, and the spread values for that asset. And now things get completely nasty. This is where things get really weird. But it's simple once you understand it, and I've documented it extensively. We are going to be doing a lot of transformations, and we're going to sort this dictionary. We want to see from lowest to highest, sorted in spread order. That is, we want to see the smallest spread to the largest spread. So what we need to do is take a special function of Python. Remember, since this is a dictionary between key and value, the value is called an item. So we want Python to actually go into this special container, take the items, take the values, and that translates to 1. The first item, the key is 0. The second item, the value or the item is 1. So of the 1 of the item, take the spread. And this is just a fancy way of shorthand of saying that we're going to specifically isolate the second part or the item, and then within the item, we're going to take the spread value as our means of sorting it. But it gets a little more complicated. After we've sorted it, we need to make sure it's returned as a dictionary. We gave the process a dictionary. We want a dictionary back. We gave the process a key value list that gave us ask, bid, and spread in a way that we could work with. We want the process to give us that type of information back, because we are now going to take this information and display it on the screen. So it has to be in the order we gave it. As you can see, up here I talk about this in detail. The key value is going to be the asset. For example, in this example, The key is USD/JPY. The value of that key is actually another dictionary. That's where X1 is. Go into the second dictionary and pick the item called spread. It sounds confusing, and it's going to take a little bit of time getting used to. And really, you don't use this very much. Only very certain circumstances does this type of a strange looking way actually get used. And this is literally the most complicated line of the entire program. It's just sorting these numbers. And that's all this one line does. It sorts the numbers based upon the spread value or how much you pay. So now that we've done that, and we've actually gotten to the point that we've got sorted numbers back, now we get into some fancy printing. We're going to be using Python's F string, or formatted strings. Now, this is saying print the word asset, but make it 12 characters long. So our header is going to be 12 characters long, but the word asset is going to be on the left-hand side, kind of like you would see in a spreadsheet. Here, same thing, print the word buy, but we want it on the right-hand side of these 12 characters. Again, just like a column in a spreadsheet. So basically what we are creating is the look of an on-screen spreadsheet. And this is going to be a little weird because we want Python to print a dash that is 12 characters long. Let's actually go into the interactive editor and see what that looks like, because it's quite interesting. So dash, so we want dash. If we do that, we get one dash. But in Python, if you put an asterisk or a star and a number after a character, you get 12 dashes. You can even do all sorts of weird stuff and get different types of display text. This shorthand lets you format your strings and do all sorts of interesting little visual graphics. So let's go back into our code. So that's all we're doing in these two lines. We're simply setting up the top of our table. Now, same thing that we did above. We're going to take the current position of our markets dictionary, and we're going to go one by one and display the asset name, the asking price. We want the spread in the middle, just like it showed up on OANDA's panel. And then we want the bid price. And you'll notice we're doing 12 characters long, but 5 of those characters need to be a decimal place. So we want 5-digit decimals. So let's see what this looks like. First, we'll just run the command by itself. It's collecting all the information and it prints the table. But it went by so fast, we didn't see half of it. So here, again, we can use the less command. And now we have our nice, pretty table created where we can actually see. We can watch. We can analyze. We can see what coin is the cheapest, or I should say what Forex pair is the cheapest for us to invest in right now. And right now, the Australian dollar USD is the cheapest on the market at only 1.3 pips. We see what we're going to pay if we buy it, and we see what we're going to pay if we were to sell it right now. And we see the columns all nicely organized, just like you would see on a spreadsheet. We have the very basic beginnings of some real information across the entire market. Not just one coin at a time, but something that we can actually take and begin to really think about in terms of what we want to trade. And the most important thing we want to focus on is how much we pay. So obviously, if we're looking at opportunity, the coin or the asset with the smallest amount of spread is going to be the best choice to start with. Now we can go into further analysis and see if that pair really is a good opportunity, or if we would be better off looking at Euro GBP or Euro USD. I personally like trading Euro USD. 1.5 pips is a good, reasonable amount. But if you happen to like the Aussie dollar USD combination, 1.3 pips is a steal. And of course, you can go down the list with the arrow keys, actually see every single Forex pair. How much is it going to cost you to actually trade it? The higher the spread, the more expensive it is to get in and out of the market. You need to be aware of that. You also need to remember that you're working with whole units, which means when you look at your bid and your ask price, for example, the Hong Kong dollar versus the Japanese currency, that's would be $18. So one unit is $18. So if you buy 100 units, you're paying $1,800. So you want to be aware of these particular sections and critical points as you look for your trading. Because some of these coins, or some of these pairs, like USD JPY, right now it's $142, one unit. And quite frankly, the spread is insane. 180 pip spread. That is crazy expensive. Any movement on this market is going to be slow and tedious for small budgets. So this is really a plethora of information that is just amazing. And right now you can see the most expensive at $398 per one single unit. And it has the highest spread as well. So you want to really stay focused on the stuff at the top of the table. And you can limit this to, say, just the first 10. For example, if you're looking to build a screening process of what items might be worth trading. First 10, first 15, ignore the rest. And quite frankly, I personally, if it starts going above 2 pips, it gets hard to make a profit. So I would actually use that as part of my filtration, so that I would probably stop right here. This would be it for me. I would make my choices from here up to the top of the table based upon the spread and how easy it would be for me to make a profit. So here we are. Let's go back into the code. The code isn't complicated, but it is shell shock to first learn the complexities or the complexness of the OANDA library itself. Now I'm going to make this code available on GitHub, and a link will be available in the description below, where you'll be able to go to GitHub and download this repository of everything we've built so far. So you'll have this code to actually look at, play with, and build on. Be sure to ask any questions if you have them. Play with this code. Look at it. Go through like I did. Stop and look at sections of each of the requests. What other information can you use or do you think would be useful to help you make a decision on whether or not you want to purchase a given asset? Don't be afraid to tinker with this and tear it apart, because this is literally the first step of building a trading bot. And if you want to build a bot that searches for opportunities, then this is the perfect way of collecting information. For example, if you want a bot that only enters when the price is the cheapest, well, you've got the first step. The first item is the smallest spread. So if you're not already in a trade, purchase the first item, and then once you make your profit, go back and look for another item to trade in that has the smallest spread. Screeners are critically important to any trader as they help weed out large amounts of information quickly and efficiently, and only give you opportunities that are within your certain limits. Let me know if you have any questions. Leave them below. And until next time.